this video we are going to create color gradient that changes with potentiometer using ESP32 that is powered up with lithium battery from SunFounder. When I rotate this, we get RGB color that is changing with this knob or potentiometer. This is very cool. Make sure to thumb up this video and also subscribe to my channel. Let's get started with this. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. This will be very cool to change the color with a knob, but the value that you see here is a predictable value that, for example, if I go all the way to the right, we are getting red, and if I go all the way to the left, again I'm getting red, and somewhere in between we are getting random different colors. And this is all done with RGB LED, which we have separate video and I explained it fully. Then we had another video explain the potentiometer or variable resistor with SunFounder's ESP32 learning kit, which is powered with lithium battery, and you can create cool projects. Come to this page, docs.sunfounder.com, scroll down until you see ESP32. Then click on ESP32 Starter Kit Main. On the left side, click on Arduino User. After that, scroll down to 6.5, Color Gradient. Click. This is the documentation for today's lesson. And it explains what we do. We are creating wonderful color with RGB and potentiometer. And here, we need ESP32 board, we need ESP32 camera extension board, breadboard, jumper wires, potentiometer, RGB LED, which we have separate video explained breadboard, how to use the breadboard. We explained how to use potentiometer, and we explained how to use RGB LED. And now here, this is RGB LED. This is a complete wiring for RGB LED. We are connecting RGB, red, green, and blue wires to 5, 26, 27, and our potentiometer will be connected to pin 14. And here is RGB LED, and this is the actual picture of the wiring. At the bottom we have the code that creates that wonderful colors, and here there are some explanation in English, which I'm going to explain it fully in the code section, and the wiring also will be explained in the wiring section. To understand RGB LED, we first let's have a look at the LED. LED is a light emitting diode. It has two pins. One pin is called anode, which is positive. The positive is always long, the anode pin, and then the other pin is called cathode, and it is short. Here is the symbol for the same LED. We have a triangle with a line, and most of the time they put 1 or 2 arrow here to show it is light. The anode is on the back side of this triangle, and the side that has line, it's called cathode. And to turn the LED on, we cannot connect it directly to the power. We have to put a resistor to reduce the amount of voltage that is coming. So we are using it as a voltage divider, right, like this. The resistor can be connected between anode and positive like this, and the cathode is going to the negative. And this is the actual shape. So this is 220 ohm resistor. You will connect it. This pin must be the anode pin, the long pin. So it has been cut and it is connected, so the LED will turn on. We can have the resistor on the other side. So the anode is connected directly to the positive, and the resistor can be on the cathode, and the effect is the same. There is no difference. And here is the RGB LED. RGB LED, however, has 3 LEDs in one. So red, green, blue, RGB, they are connected like that. If the anodes are all connected together, it's called common anode, and we have 1 pin for the positive, and then we have separate pins for the cathode. So this is called common anode, or we can have it as like this, common cathode, which the common will be connected to the negative, and the anode are separate, so we can control each. RGB LED is sold like this with 4 pins, or as a surface mounted device like this. Sometimes you can see it as a module which all the resistors are already mounted, so you have all the 4 pins and you will just connect it. So we have common and then red, green, blue. For the common anode, the resistors are connected at the cathode because the anode is common, so we are connecting each resistor for each LED in this package. Or we can, if it is common cathode, then the cathode will be connected to the ground, and the resistors will be connected to the anode of each resistor to divide the voltage and allow 2 volts for the LED. Here's the actual RGB, and here is the picture with a proper explanation from SunFounder. So if we divide it in 2 pin of the right, 2 pin on the left, the 2 pin on the left, the second one from the left is common, which is the longest one, and here we can see this is the longer pin, and that is our common. And then from the left we have red, green, blue, R, G, and B, and here this is our R, and then G, and then B. So you cannot make mistake. If you put it like this, then the long is on the right side, and that's incorrect. So we are going to use it like this. Now I'm on the Bing search engine. Just type RGB color picker with slider, and the first one that comes, click on it. To understand the color of RGB, we have to first know that all colors can be created, or any color can be created from combination of R, G, and B. This area shows the actual color that we have created, and because there is no color, the red is 0, the value is red is 0, green is 0, and blue is 0, so we see black color. Now if I move this, you see some red here, and this is maximum value. Why 255? Because it's 2 to the power 8. So we have 8-bit color resolution, which means from here to here we have 255 steps to add or adjust the color. Of course, there are higher bit rates that can be done. For our purpose, we are using 8 bits. So this is red. Now if I slide it back, the value, you just read it here, pay attention. And this is green, maximum green, light green, and then dark. And then this is blue. So we got these 3 colors. Now the value could be shown also in hex. Pay pay attention, this is the hex value, but those are RGB, but we are paying attention to this. Now let's have red and let's put green. So this is red, this is green, and if you combine it, you get yellow color. And if we have red and if you put blue, then we get pink color. So this is the combination of red and blue. Now I'm bringing that down. This is green now. Green is the maximum. Now if I bring red, you know it was yellow, but blue and green will create the sepia, this color. And if I bring all the colors, it will be white. This is interesting. If you combine the right proportion of R, G, and B, red, green, and blue, you will create a white color. And now if we pay attention, this is 255, 255, 255. Now this color is red is 0, and then we have green and blue, 255, 255. That's why we are getting. And if you want pink, so red is maximum 255, and then 255 is a blue. If we put them at the middle, you will create a darker pink, because we are moving these two together, 82, 82, or 83, so they will be the same. Now the fun starts when you play with these values and you create like different color. Orange, you see somewhere here, if we have full red and blue is 0, green is at the middle, that's you see we are creating orange. If I bring that here and this, we have different kind of blue. So we, with all this, we can create different color that we want, and we are going to practically test it and see it here. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger, so you can connect it and charge it and disconnect, and later on you can use it with a lot of power, so you can power up your application very easily. For this lesson, we just need the variable resistor or potentiometer. We need this 3-pin RGB LED, wires and breadboard, and we need 220 ohm resistor. Now to do the wiring, one pin is longer, which is a second pin. If you hold it like this, it will be incorrect, so hold it this way. This longer pin is the common, and then from the left R, G, and B. And let's start by inserting the RGB LED on this side somewhere. All 4 pins should be in one row like this. So it has been inserted. Now get the 220 ohm resistor, and except with the ground, from the left connect one 220 ohm resistor, just bend it, and from that side bring it to this side of breadboard like this. This is not connected, so we are bringing it from that side to this side and connect it to the third pin from the left, because the second pin is a common. And connect it to the other side, and the same way for the third one. So here this has been connected, and I have here 3 wires, red, green, blue, and let's start from the left. Connect R to this resistor on this line. Anywhere that the resistor is connected on this line, that's fine. Red, and then green, to the second resistor and blue to the third one. And from the common, get the wire and connect it somewhere on this blue line on this side. This will be our ground. I'm going to connect it in here because it doesn't matter where. Then let's insert our potentiometer. It has 3 pins as I've introduced it in the introduction. So the 2 pins are straight and 1 is out, so that's the third pin. Insert it somewhere here such that you have holes left. We will connect blue pin to the middle pin. And here on the left side it's pink, I'm using yellow. Connect it to the left pin. And we are connecting the right pin from the right side and connect it somewhere on the blue line. This is now done. This is R is connected to 27, then 26 and 25, and this is connected to 14. So R is connected to pin 27. You can connect it to pin 27 in here, but I'm going to connect it so it's secured in this terminal. 27, 26 and 25 in the same order, RGB. Now we have one blue pin here left. Now the blue pin, let's connect the blue pin, which is the middle pin, to pin 14. 14 is beside this pin, beside 27. Now the yellow will be connected to 3.3 volts here. You can connect it at this pin, but I'm going to connect it at this terminal and tighten it. This portion is done. We need now a ground wire. For the ground, we can connect it either from that ground or on this side. Let's connect it to this ground and connect this. On the diagram, they have forgotten to show it, but this will be connected on the blue line anywhere. Let's say connect it in here. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads, then ESP32 Starter Kit Main on the right side. Double click to open it, double click on C, double click on Codes, and scroll down until you see 6.5. Color gradient, select, click to open the folder and select the file, click open here to open it. So we have defined here pin 27, 26 and 25 as red pin, green pin and blue pin variables, which are type of integer and constant, so they cannot be changed. And then we have defined the red, green and blue channel. These are variables, and we have assigned channel 0, 1 and 2 of pulse width modulation or PWM from ESP32. We have set also the frequency. The frequency was 5000, and then the resolution, this is 8-bit, which becomes 2 to the power 8 to 256 possible color level, and these are all constant. And here we have defined pin 14 as a knob pin where the potentiometer is connected. We put here define, and when you put define, it automatically detects the type, so it becomes integer of constant, so this cannot be changed as well. Inside the setup, which starts from here to here, we have the following lines. First, using LEDC, we set the RGB, the red channel with a frequency and resolution. So this is setting the channel, and this is setting for green, and this is for blue. After setting those, then we have to attach them using LEDC attach pin. So attaching the pin that we have defined here at 27, 26, and 25 to particular channel which we defined, channel 0 and 1 and 2 in here. So we are attaching the pin to the channel, green pin to the green channel, blue pin to the blue channel. And then in this line, we using pin mode, we define the knob pin, which is 14 at the top, as input pull-up. So this will always be high if there is no connection or no voltage. So this will have always high voltage. Now this is the loop which ends in here. We first use analog read to read the knob pin. This will give us a value between 0 to 4095, and the result of this reading will be stored in a variable called knob value of type integer. Now this line here, it says normalizing the knob value. We are getting the value, and because it's integer, we are converting it to float. Just this is called casting. In front of the variable, just put the integer, float, or char, and then you can convert it. And then we are dividing it by 4095, which said it's the maximum value, and it's stored now in a variable called hue of type float. Now, strangely enough, now we got hue times 360. So because we want to make sure it's the value that we have is multiple of 360, and that is our hue value. Integer called to the hue value of n here, and we have defined red, green, blue hue value of type integer, and this hue that we have, we are passing it to a hue to RGB function, which is at the bottom of the code, and it gets this hue, and this ampersand in front of this red, green, and blue, we are passing them by reference, which means these value will go to this function, and this function will be allowed to change the values even though they are outside this scope. So let's have a look at this, what happens when we receive the whole number and then red, green, and blue. Here we have hue, so we receive hue, and here this is also this asterisk means get by reference, so we get the reference value of those, and there is some calculation. All these calculations we are getting integer value, and is stored in a variable called red, and this asterisk mean go updated by reference. So this is updating the value, so the R, G, and B are getting random value, multiple of 255. And now if I come back here, then we have the value red, green, and blue have been updated, and we can say set color, and we pass the red, green, and blue. Now this function is also just below this, so the value that we pass arrives here, and we have another name for them. It could be the same name or different name of type integer, red, green, and blue, and we use LEDC write, and we set a channel, and we pass the color. So this goes to channel red, this goes for channel green and to blue, and we see the color value that is associated to this. Here we could have 0, or which is turned off, or we could have 255. So the red will be now the maximum red, and the green the same way. If you have 255, it will be maximum green and maximum blue. But I'm not gonna do that because we have to have the dynamic value of red. And let me upload the code now. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board have been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Okay, so now this is a demonstration. I've connected the project via this extension board, which is connected to the lithium battery, which is provided with a kit. Everything that you see here is from SunFounder's ESP32 learning kit. But the value that you see here is a predictable value that, for example, if I go all the way to the right, we are getting red. And if I go all the way to the left, again, I'm getting red. And somewhere in between, we are getting random different colors. And this is all done with RGB LED, which